Design DFA where input is valid if it contains at least one occurrence of a BBB string. So we have to find or design a DFA for the one occurrence of a BBB string. So we have find the solution. First is a theory point. So in theory we write a definition of a DFA. So for definition of a DFA, see my first lecture of a DFA. The next point is a logic behind that problem. Input string, input. So we have a BBB input. So this is BB for input variable. It will be AB. So then output will be S no, and states, that is a QS, which is a starting state. Q0 state always for A, Q1 for always B. Always remember in DFA when we given any string from AB format or 01 format, always Q0 in 01 for binary. Suppose input is given 01, so always Q0 for 0, Q1 for 1 state, and always in the AB problems input is given AB, then Q0 has a A state and B has a Q1 state. Always remember. For B we divide this. B is a substring, so B for B having also state. Then check for BB having a Q2 state. Then we check BBB Q3, that having a state BBB. So this is a states. So next point is a implementation. In implementation we draw the transition table. We having a starting state BBB, because so we have to find a substring BBB. So implementation. In implementation we draw the transition table. This is our transition table. States input AB. States are QS, Q0, Q1, Q2, Q3. Q3 is final state. QS is a start state. For A we check for A we have a state Q0. We check for B. For understand we write here A, B, B, B and B, B, B. For B we have a state Q1. Then A, here is a upside A. For A, here is A upside A having no any state, we cut A. For A we have a state Q0. Then we check for A or B. AB having not any state, we cut A. Then we have a state B. Then we check for BA. So BA not any string, so we cut B. A for A having a Q0. Then we check BB. So BB we have a state Q2. So here is a Q2. Then for BBA having no any state, we cut B. For BA we having no any state, for cut B. A we having a state Q0. Then we check BB having a state Q3. In BBA each contain a state. So here is a Q3 BBB state. So next one is a BBB. So here is also in BBB contain Q3. So always remember this is the trap state which is present in a that contains problem or in that contains problem. Always remember last state is the same. So we check we having input we can state merge or not. So here is this two state having same input, so we merge that both state. After merging our transition table will be states input A, B, Q0, Q1, Q2, Q3. Q3 is a final state. Q0 having a Q0, Q1, Q1, Q0, Q2, Q2 having a Q0, Q3, Q3 having a Q3, Q3. So this is a start state. Because we merge both state, we know merging rule. So to understand the merging rule, so go to my last lectures, previous lectures. We have to one suggestion for my all students. So we take a lectures of a talk. So for better understanding a talk, we see my all previous videos, then we understand the what is actual talk. So we follow only one channel that we have for better understanding the talk concept. Suppose we check or see the playlist of my DFA or FA. Suppose we check we having a different teacher, having a different type of a teaching skill or teaching method. So we see my DFA one lecture and see the another channel another lecture. So we'll confuse with both methods. So follow only one method or one channel till all talk videos for understanding. When we check one channel from one video, second video for another channel, then we will confuse with talk. So always remember, we follow my channel or another channel till all videos, not one from here, one from another. So this is a confusion for viewers. So for avoiding confusion, follow only one channel for talk, and your choice, my channel or other channel, but till first video to last video, not change this or this channel. So this will be confusing for viewers. So this is a transition table. After merging, we draw a transition diagram. Q0 starting state, Q1, Q2, Q3. Final state, Q3 is a final state always in a double circle. Q0 to Q1 B, Q0 to Q0 A, Q1 to Q0 A, Q1 to Q2 B, Q2 to Q0 A, Q2 to Q3 B, Q3 to Q3 AB.